we are going to start our new section, dual operators. Okay, let us recall what is X star. X star is set of all bounded linear functionals on X. That means set of all f such that f is a function from x to k such that f is bounded. Now what do you mean by f is bounded? There exists a c belongs to k such that modulus of f of x is less than or equal to c into norm of x. Okay. Now let a be let a from x to y be a bounded operator. Now what do you mean by bounded operator? There exists a c such that norm of x is less than or equal to c into norm of x. Okay. Here a of x will be in y. So here norm is ay and here with respect to x. Okay. Now suppose phi is a linear functional on y. That means phi is a map from y to k. Okay. Now what about a is a map from x to y, phi is a map from y to k. What about phi composition A? Clearly phi composition A is a map from x to k. Now we are going to prove this phi composition A is a linear function. Okay. We denote let f of x is equal to phi of a of x or phi of ax. Okay. Now clearly f is a map from x to k. So what about the range? Range is a subset of k. That means if we prove f is a linear, then clearly f is a linear function. Now we have to prove f is a linear function. Now you choose some x comma y belongs to x, and we have to prove that f of cx plus y is equal to c into f of x plus f of y. Okay, clear? Now what is actually f of cx plus y? By definition, f of cx plus y is equal to phi of a cx plus y. But a is a linear, therefore phi of c ax plus ay. Phi is also linear, therefore this is actually c phi of ax plus phi of ay, and this is equal to c phi ax is f of x plus phi ay is f of y. F of cx plus y is equal to c f of x plus f of y. This implies f is linear. This is true for every x comma y belongs to x. This implies f is a linear functional on x. Okay. Thus, for every phi belongs to y star, we get a f belongs to x star. Okay. So, now we are going to define a map. Define a map A star. Define a map A star from y star to x star. As for every phi belongs to y star, we get a f belongs to x star. We define this map like A star phi is equal to f. Okay. Now we are going to prove this A star is linear. Okay. Now we are going to prove A star is linear. Okay. Let phi comma psi belongs to y star. Okay. Suppose A star phi is equal to F and A star psi equal to G. Okay. Now what's the meaning of that? A star psi is equal to F. This implies actually f of x is equal to phi. Okay. Similarly, A star psi equal to G implies g of x is equal to psi of ax. Okay. Now what we have to prove? We have to prove A star of some C psi plus C phi plus psi is equal to C A star psi plus A star phi plus A star psi. Okay. Now what is actually C phi plus psi? This of A of x is equal to, by definition, this is equal to C psi of Ax plus psi of Ax. Okay. And this is equal to C psi of Ax is actually f of x. C f of x plus C psi of g of x. And this is equal to Cf plus g of x. Therefore, C psi, we have psi Ax is actually A star psi. Therefore, what is actually A star C psi plus psi, C phi plus psi. What is actually this is actually C phi plus psi of X. Okay, A star phi is F, A star phi of X is equal to actually F of X, that is equal to psi of X. Okay, from this we get this is equal to Cf plus g of x, that is A star C psi C phi plus psi is equal to Cf plus g, and this is equal to C F is A star phi plus g is A star psi. This implies A star C phi plus psi equal to C A star phi plus A star psi. This implies A star is linear. Okay, thus we have defined a map A star from Y star to X star as A star phi is equal to F. Okay, that is actually A star phi of x is equal to f of x, but that is actually phi of x. Okay, thus we get for every x belongs to x and phi belongs to y star, phi of Ax is equal to A star phi of x. Okay, we have this result. Now we are going to prove norm of A is equal to norm of A star. Okay. Now we are going to prove norm of A star is equal to norm of A. Okay. What is actually norm of A? A is a bounded operator. Norm of A equal to actually supremum x not equal to 0, norm of Ax by norm of x, and that is same as supremum of norm of x equal to 1, norm of Ax. Okay, here Ax and our y. Okay, but we have proved the result. There is another result. Norm of x over x is same as supremum of norm of f equal to 1, norm of, sorry, modulus of f of x. We have proved yesterday. Okay, using this result here, we get norm of a equal to supremum of norm of x equal to 1. And what about norm of axy? This is equal to supremum of ax here. You can consider norm of phi equal to 1 modulus of phi of ax. Okay. So using the same result, this result, here norm of x, here ax, therefore this become norm of ax. Okay. Here ax is clearly A is a map from x to y. Therefore ax belongs to y. Therefore we have take this norm here y. Okay, and this is equal to supremum of, we can interchange norm of phi equal to 1, supremum of norm of x equal to 1 modulus of phi of x. Okay, and this supremum norm phi equal to 1, supremum norm of x. Okay, and this is equal to supremum of norm phi equal to 1, supremum of norm of x equal to 1. Now what is phi ax? Phi ax is same as a star phi x. A star phi of x. Okay, and this is equal to what about this value? Supremum of norm of phi equal to 1. Here a star phi of x. Okay, norm of x equal to 1, and that is same as norm of a star phi. Okay, that is same as norm of a star phi. A star phi over the norm x star. Okay, because a star phi, a star is a map from y star to x star. Therefore a star phi belongs to x star. Therefore norm under x star. Here supremum of norm phi equal to 1, a star phi, and that's equal to norm of a star. Norm of a is supremum of norm of x equal to 1, norm of ax. Okay, here supremum of norm of phi equal to 1, norm of a star phi. This implies this is equal to norm of a star. That means thus we get norm of a is same as norm of a star. Okay, a is a bounded linear operator, therefore a star is also a bounded linear operator, and a star is a map from y star to x star. So a star is a bounded linear operator on y star. Okay. Thus we get for any a from operator bounded linear operator a from x to y and a map phi from y to k, linear functional y to k, there exists a f from bounded linear functional x to k such that f is equal to phi a. Okay, or f of x is equal to phi of ax. And using this, we have defined a map of a star from y star to x star as a star phi is equal to f, and this is same as phi. Okay, actually phi ax equal to, okay, So this operator, we have proved A star is a bounded linear operator, and this operator A star is called dual operator to the operator A. Okay.